So, on that note, please welcome the most accomplished 8th Chief Scientist of Australia, Dr. Alan Finkel.
Thank you so much, Jens. You're a parachutist, apparently. Well, you parachuted me right into this one. You also made the comment about noise. I'm used to working in a noisy background, but I've been to lots and lots of international conferences, and I've got to say that this convention centre we've got here is right up there with the kinds of convention centres that I've, in my working life, experienced going to in Washington, DC, in New Orleans, Los Angeles and Boston. So we should be very proud of this centre itself. Thank you to Colin Hunter for the welcome, to Minister Martin Pakula, Robbie Clark, and to you, Jens. Now, as I just indicated, I've been to a lot of conferences in my working life, but I also go to a lot of conferences as Chief Scientist. And I think I've spotted a general trend, and I'm sure it applies to manufacturing as well. And that's up on stage, there are any number of people who don't work in a given industry who think that they know exactly what people who do work in that industry ought to do. And I'm certain there are any number of people who've never set foot in a factory who want to tell manufacturers like yourselves exactly what you ought to do about a new technological phenomenon called artificial intelligence, AI. Now, there's no doubt that talking about AI is important, and ignoring all those people who want to tell you how to use it would be a terrible mistake. But today, I actually want to flip the script. And instead of talking about what manufacturing needs to learn about AI, I want to talk about what AI development needs to learn from manufacturing. And I want to encourage all of you who are here today to reflect on how the systems that we have developed to ensure quality and safety in manufacturing can help us to achieve a world of responsible AI. Well, I thought to begin I should lay out my credentials. As it happens, I come from a manufacturing family. My father, David Finkel, was a maker of women's clothing. He was born in an industrial town in Poland named Białystok, and it was famous then, as it is famous now, for making two things, vodka and carpets. And if Dad had stayed in Poland, he might have followed the path that my grandfather had planned for him, which was to go off to another part of the country and start a rug-making business. But of course, all of those plans were shattered by the German invasion, and Dad was forced to seek refuge in Siberia instead. Then, as soon as he could after the end of the Second World War, Dad got on a boat and he came to Australia with nothing. Well, at least he had nothing in his pockets, but he had courage and initiative in spades. And he also knew factories. He'd known them all his life. And he knew that manufacturing is how migrants who start with nothing can get ahead. And so that's exactly what he did. And he built a clothing business in Melbourne that at its height employed over 400 workers. And he gave many people, most of them were migrants just like him, their start. Now, I admired my father and his business acumen enormously. But I never expected to follow him into manufacturing. When I left school, my plan was to study engineering. And I did. I got my degree and I started my PhD. Gotta wait for this. I started my PhD on measuring the electrical activity in the brains of snails. Now, it turns out to be extremely difficult to study the basics of what goes on in brains, even snail brains. And I became obsessed with the need to have better measurement tools to do that work. And eventually I came up with the design of a new kind of amplifier, which was called a voltage clamp. And you don't need to know anything about what a voltage clamp amplifier actually is, except for the fact that it overcame a big limitation in all the existing designs. And people started asking me where could they buy my electronic amplifiers that I was just making for my own use in research. And I realized eventually that in order for people to buy them, I would have to make them. And so that's what I decided to do. And in 1983, at the age of 30, I said goodbye to my research career at the Australian National University, and I went with my wife to Silicon Valley in California. A migrant, without suppliers, without customers, even without a workspace. Everything I had was basically in my head. I set up a company called Axon Instruments, and I went into manufacturing just like my father, head first. Axon was a one-man company, and that one man was me, which made it very easy to get unanimous agreement on a wages policy, but very hard going in every other respect. But I survived that first nerve-shattering year, and so did Axon. I got that electronic amplifier onto the market. We actually turned a profit, and even though my parts cost alone was as much as the retail price of the nearest competition, which meant that to cover direct and indirect labour and all those other overheads, and you guys, you manufacturers, you understand this, I would have to charge twice as much as the competition, at least twice as much as the competition. Now, I was a novice in business, but it did occur to me that this might be a problem. So I made a panicked phone call back to Australia. My father had died a long time prior, and it was my stepfather, also an experienced businessman, who picked up the phone. Alan, he said to me, is your product truly better than the competition? Absolutely, I said. Then charge what you need to charge, Eric said to me, because quality is remembered long after price is forgotten. Quality is remembered long after price is forgotten. For me, that was manufacturing 101. But then came manufacturing 201, which told me that you're only as good as your most recent product. So for the next 2 decades, I worked constantly in my company, for my company, and on my company, making new products and then making them better. And any of you here today who have built a thriving manufacturing business and kept it going, you have my respect. By 2004, over there in Silicon Valley, we employed close to 150 people. The company was still expanding, and I decided that the time had come for me personally to move on. I sold the company. I agreed to stick around for 18 months as the Chief Technology Officer of the acquiring company. And then I woke up January the 1st, 2006, a free agent. I tried retirement. It was awful. So I went back to work. And now I've ended up as Australia's on-call scientific advisor and in-house engineer. Now, looking back, I can match the phases of that story against the bigger trajectory of history. My father's factory, that was Industry 2.0 at its height. It was the golden age of capitalism, when the population was growing, and so was the economy, building on the massive technology dividend from the Second World War. My company, Axon Instruments, that was Industry 3.0, the computer age. I founded Axon in the same year that IBM started to roll out the very first personal computer. And actually, a personal computer was one of my first big investments. It cost me $10,000 US, and all it had, besides its microprocessor, was a minuscule 10 megabyte hard disk, and now we talk gigabytes and terabytes, and 384 kilobytes of memory. I'm not sure anybody here today even knows what a kilobyte is, but it's small. $10,000 US in 1983, which is about 37,000 Australian dollars today for a PC. And then I sold the company 21 years later just as Apple was rolling out the iPhone. So, in my time as CEO, in Industry 3.0, I saw every aspect of manufacturing transform. And now, your factories today, Industry 4.0, the era when artificial intelligence is ascendant, coupled with rapidly accelerating progress in the Internet of Things, additive manufacturing, nanotechnology, biotechnology, material science, energy storage, digitalization, and embedded computing. So why do we say that we are entering a different era, an era with AI at its core? Well, if you look at geology, the geologists say that we can mark off a new epoch in world history if we see a universal signal, which means that it's something that's registering itself all over the globe. And if it shows up as a distinct shift when we look back through the layers of rocks. By analogy, we enter a new industrial era if we have a force that becomes ubiquitous, that registers on the economic indicators. And to be fair, we haven't seen a definite AI productivity spike yet. But we wouldn't really expect to, because we're still in a learning phase, when the experiments are risky and often they don't go quite right. Let me give you an example. The world famous Fluffbot. Fluffbot was a robot developed for Tesla's Gigafactory in Nevada, where they make lots of battery packs. And Fluffbot had one job, to put fiberglass insulation fluff around the batteries in the battery pack. A piece of cake for a human, seriously advanced for a machine. And Fluffbot literally fluffed it. He couldn't pick up the fiberglass reliably, and when he did pick up the fiberglass, he couldn't find the battery, so he would just drop it somewhere else. Tesla concluded that Fluffbot wasn't helping, and they retired him. And the media loves these kinds of stories, the failures. But it would be wrong to see the failures and miss the trend. The trend is inexorable. Remember, it took us decades to see the productivity gains from developments that we now understand to be transformative, such as electricity and IT. And the trajectory in AI is very, very clear. The individual efforts, they're becoming bigger and bolder. And collectively, they're surging into a wave. Already, today, AI routes trucks. AI makes more share trades than humans. AI, in some places, chooses the news. AI writes the news. In China, AI even presents the news on TV. AI is in security cameras. An estimated 1 billion of AI-enabled security cameras by the end of next year. AI is in our telephones, our smartphones. There are 4 billion of them already equipped with AI assistance. AI drives cars. But who's impressed by cars? Think trucks. In Australia, AI is driving dump trucks on mine sites. And these are trucks that weigh 350 tonnes. They're the size of 2-storey houses. And they politely give way to each other at intersections. No driver. And AI drives the trains 1,000 kilometres to the ports. On the east coast, on the other side of the country, at the port of Brisbane, giant AI straddle carriers stack and load the cargo. And of course, AI is seeping into every aspect of manufacturing. And manufacturing companies are buying up AI talent as fast as universities can churn that talent out. 10 years ago, we would argue about the big and abstract threat of the robot apocalypse. Today, we are grappling with the real and present impacts of AI on our businesses, our jobs, and our children. In short, the impact of AI on our society. Do we want to live in a world where employees can be constantly monitored and the least productive workers automatically sacked? Who should be reading our job applications and our mortgage paperwork and our medical scans? Should it be humans or machines? When is an automated driving system or production line sufficiently safe to be worthy of our trust? And how do you transition decision-making responsibility to that system over time, whilst keeping the human operators alert and engaged? Now, all of these questions are complicated by the massive information gap between the people who develop the AI and the people who deploy it, and the bigger gap again to the people whose lives it affects. As consumers, we don't see the algorithms at work in our news feeds, or know if our job applications will be read in the first instance by a human being or a machine. And even when we do see the AI in a physical form, such as the smart gates when you go in and out of customs, many people don't make the connection that this is AI at work. We're still trying to find our way through an increasingly angry debate. On the one hand, there are people who insist that AI needs to be banned, smashing the glass and pulling the emergency brake on the train of progress. On the other hand, there are people who insist that any attempt at government control of AI is premature, that technological development and the wonders that it delivers blossom best in an unregulated free-for-all. On the first part, people with scruples give up on building AI with ethics. And on the second part, we say that scruples and ethics don't count. And either way, the unscrupulous win. But I look at the long history of manufacturers bringing new technology into our lives, and I think of technologies that are in many cases inherently dangerous, like electricity and cars. But we've accepted these technologies in our lives for decades. We've managed them. And I also think of technologies such as medicines and how we've learned to minimise the adverse side effects associated with their tremendous power to heal. We trust in our power to manage these technologies rather than ban them. And when you think about all the things that have to go right every time for a safe and effective product to arrive in our hands at a price that we can afford, at the moment we want, in a country like ours where doing business isn't cheap, that level of confidence is extraordinary. And it didn't exist at the dawn of Industry 2.0, and it still doesn't exist in many places around the world today. Quality is the Australian brand. Quality assurance is the Australian strength. And that says to me that there's an incredible repository of knowledge and experience in manufacturing right here. And there's a lot to carry forward from manufacturing to AI development. So let's think for a moment about how quality assurance works in manufacturing. And as a manufacturer, you understand that your practices are guided by a mesh of interlocking systems, all designed to strike the optimal balance between quality, speed, and safety. At one end of the spectrum is legislation, hard requirements with criminal and civil penalties. Then, as you move away from there along the spectrum, there are industry codes and standards, sometimes binding, sometimes voluntary. But you adhere to them because that's what your peers and your customers expect. Next on the spectrum are the practices that you adopt internally. Feedback loops to your customers, data gathering, project evaluations, employee training. And finally, there are measures designed to inform consumers about what products do and how they are made so that they can give their dollars to the companies that line up best with those consumers' values. When you first go into business, you probably would think that these things are constraining. In time, you realise that good regulation is a CEO's best friend. It's the way you get permission from the community to be in the game. Once you know the rules and you know you comply with them, you can get the backing from investors and play to win. It means it's good business to do the right thing. And that's what we should develop around AI. Not one law of AI, but a spectrum of approaches, legal, financial and cultural, all working together. I've been thinking in particular about the consumer end of the spectrum. Now, if you're in the market yourself to buy an AI baby monitor, or if you're a business thinking about installing AI security cameras in your warehouse, how do you know if the product and the company that created it are trustworthy? You could read the 100-page disclaimer, but you won't. Maybe if you're a government department with a big procurement budget, you can put more resources into doing the due diligence. But what exactly are you trying to find out? What you want to know is, has the AI been trained on a quality data set? And how, for example, would you know that an AI used for targeting job ads for the best candidates isn't biased? How can you be confident that the system you installed last week will still be properly supported in 2 years' time? And even if you do have your own idea of good practice, how do the AI developers come to understand your expectations? I was turning this problem over in my mind, and I thought about the efforts that Australian industry has made in recent years to clean up the supply chain in partnership with many activists in the community. A consumer just can't tell if a t-shirt, they can't tell by looking at it, if a t-shirt has been produced with slave labour, or if the grower of their coffee beans was paid a fair price. But they can look for the fair trade mark, which tells them that the product complies with a minimum standard. Then I thought about my own experience many years ago, taking my company along the journey to become an ISO 9000 certified company. In my company, Axon Instruments, we needed ISO 9000 certification in order to be able to put onto the market a new product that we were developing that inserted an electrode 10 centimetres deep into human brains, living human beings, during neurosurgery to treat the symptom of Parkinson's disease. That's a big deal, going into brains. So we needed GMP. And what we discovered is the beauty of the ISO standards, the ISO 9000 standards in particular, is that they give you a process for achieving quality by design, rather than by testing and rejecting. They force you to bake high expectations into your business practices, and they keep you honest by a combination of internal and external audits. At Axon, we maintain these exacting design and business practices for our non-medical products as well, because they made us a better company and they gave us a commercial edge. So imagine if we could do the same with AI. Develop a standard and certification system for quality, safety and ethics. Now, in the past, I've outlined one possible model for consumer products, such as a digital assistant. And the model that I outlined, I called it the Turing certificate, in honour of the legendary Alan Turing, regarded as the father of AI. But mine is just one of the many ideas in this space. In fact, I've just come back from the United States, where I met the Chief Scientific Advisor to the President, a gentleman named Kelvin Drugemeyer. And his office is taking the lead on an executive order signed by the President in February of this year. And that executive order commits the federal government to leadership on AI governance in its own practice and in the standards that it applies to others. That includes the development of technical standards for reliable, robust, trustworthy, secure, portable and interoperable AI systems. all done in consultation with industry, and it's a process that is now underway. The message is clear. America wants a rule book, and they want Americans to write their rule book. Over in Europe, the European Commission has just kicked off a large-scale pilot of its ethics guidelines for trustworthy AI. It's a set of 7 principles, supported by a list of practical questions that you, as CEOs and executive leadership, need to consider, whether you're a developer or a purchaser. For example, some of those questions are: did you put in place ways to measure your system, to measure whether your system is making an unacceptable amount of inaccurate predictions? Or, how are you verifying that your data sets have not been compromised or hacked? Now, the idea of this pilot is to test that set of questions to ensure that the guidelines can actually be embedded in practice. Here in Australia, the CSIRO's division called Data 61 is now consulting on an Australian AI ethics framework, which was commissioned by the government in last year's federal budget. The discussion paper is out there, and you've got until the end of this month, if you would like, to make a submission. There will be other calls for your input on multiple frameworks as we get down to work on that spectrum of rules. So, why should Australian manufacturers pay attention? Well, first, because it's very much in your interest to opt in. Imagine if consumers who currently think of all things AI as an impenetrable fog, imagine if they had some capacity to distinguish between the good and the bad. How much easier would it be to win support for the AI tools that you want to adopt if you could point to a rigorous external standard? In particular, how much easier would it be to do business with big customers who will be willing to pay a premium for quality, such as governments? We know that Australian manufacturers compete on quality, safety and ethics. So we should get behind a scheme that makes those qualities count. And second, if it's in your interest to opt in, then it's also in your interest to get involved in the standard development process. Today, you've got the experience with quality assurance approaches that work. You know that we're strengthened by good regulation. You can bring your perspective to best practice requirements for AI. It's still going to be a decade of tricky decisions, and everyone here will be making them. Am I glad that I'm a failed retiree turned public servant these days instead of being a CEO? Yes, you bet. It's nice not to be responsible every minute for the future of the company and its employees. Being a CEO is tough. But even to this day, my analysis and advice that I give to governments and others is informed by my experience as a manufacturer. The reality is that we know more than we think we know. So, from one proud son of a manufacturing family to the manufacturing family here today, enjoy this conference. And in the closing salutation of my generation, may the force be with you. Thank you.